So remember, when we're talking about probability, we are looking at two separate items, right? The probability of something happening, so P sub x. The probability of some event happening is the number of events that you are looking at, right? How many times is it going to happen over the total number of events, right? It's what you want out of the total. Okay, and that ratio or that decimal, that percentage, so we're going to write it as a percentage. Okay, so we're going to use our calculators and take your decimal and times it by 100, is the probability of some event happening. Okay, we use it with geometric probability as in a point coming from a certain area, but this is regular probability, and it's got really nothing to do with geometry. But it's part of the TEK, so we're going to talk about it. So we have 500 fifth graders were asked what their favorite subject was, and these were their responses. Okay, we have responses broken up by gender, so we have male responses and female responses. And then we have responses broken up by subject, right? Some liked math, science, social studies, art, music, some like PE. And then these are the totals, okay? So these are, right, your total number of events, but these are also the number of events that we're talking about. So let's look at some of these probabilities, right, given this nice chart. So our first question says, what is the probability that a student chosen at random, right? Probability has to happen at random. If it's not happening at random, then it's not probability anymore. It's just choice. Will be a female. Okay, so a probability that a student will be female. So we have number of female students over the total number of students. So we're looking at our table, right? How many females were there? 292 females answered. And what was our total number of students? 500. Okay, so we have a 292 out of 500, which you're going to put in your calculator, right? And change to a percentage, so that's 0.58. Probably something, which rounds to 58%. Okay, and of course I would like for you to have at least one decimal, right? 2 is probably unnecessary with probability, but 58 point something percent, okay, from here on out. Okay, so that's probability. Let's see, at random, a student at random will like science the best. So how many students like science? 127 students like science. It doesn't say girl students or boy students. It says total students that like science. There are 127 kids that like science out of 500 kids. Right? So we're just talking about the total numbers. And when we multiply this and divide it and times it by 100, we get 25.4%. Right? 1/4 of the population likes science the best. Okay, 25%. So you have a 1 in 4 chance of picking a random kid that likes science. Okay, a random student that will like social studies. How many of these kids like social studies? Right, not very many. 42, and we divide that by 500. Gives us an 8.4. So 1 out of, or rather, 42 out of 500. Right? Not a very high percentage. Okay, number 4. What is the probability that a student chosen at random will be a male that likes math? Males that like math. Okay, so now we're only looking at the males. So how many males like math? 44 males like math. Out of how many males are there? 208, right? So now that we're only talking about males, we're not talking about all the students. We're only talking about the males. So what's the probability that a male will like math? 21.1%. So I guess we're walking this one back then. So we do have, in fact, a 44. So 44 is still the number of males that like math. But this is going to be out of all the students, right? Still out of 500. 8.8%. So we're looking at the number of males that like math compared to everybody, not just the males. So correct, we don't know that it is a male to begin with. So even less numbers. Okay, so then 5, what about a female? So we're looking at the females that like music. Females that like music are 55 out of 500. 55 out of 500 is 11%. Right? So we're using our table to find these values and compare them to everything. Okay, the next one. Given that a student is male, so now we are only looking at the male population, and there are a total of 208 males that answered this survey. What is the probability that he will like PE?
52 over 2 boys.
So there are PE 52 kids, 52 boys that like PE the best, and 208 is our total. So 52 over 208 is 25%, right? A 1 in 4 chance of picking a boy who likes PE the best. Given that a student is female, what is the probability that she will like social studies? So how many females are there? 292, and social studies is 36. So 36 out of 292. Which, what does our calculator say is that?
12.3%.
12.3%. Okay, so we're looking at the table to figure out how many of each of these types of students there are, and either comparing them to the total number of students or the total number for that specific gender if we know that it is a specific gender. Okay, so 2 different types of problems when it comes to these conditional probabilities. But there's other types of probabilities also. So this is independent and dependent. Okay, but the idea is still the same. We're looking for the number of events that we want over the total number of events. Okay, so let's see. There's some websites that you can go to read about extra things. They're pretty good. Okay, example, an opaque bag, right? Opaque means not see-through. Translucent or transparent means see-through. Opaque means not see-through. Contains 6 blue, 9 red, 4 green, 4 orange, and 5 black marbles. Okay, so what is the probability of randomly drawing a blue marble? Okay, so we have to figure out how many blue marbles are there. There are 6 blue marbles. And then what's the total number of marbles? So we have to add 6 plus 9 plus 4 plus 4 plus 5, and that is 28. So 6 divided by 28 as a percentage is 21.4%. Okay, so it's the number that we want divided by the total number of options. Right? What about the probability of drawing a green marble? There are 4 green marbles out of 28.
And that would be 14.2%.
Okay, so we're looking for how many options do we have over the total number of options. Okay, red or and orange. Okay, so red or. So how many red marbles are there? 9. How many orange marbles? 4, right? So how many total options do we have? 13 total options. So we are adding those 2 values together before we are making the fraction. We have 9 red options and 4 oranges. So we add them for a 13. We have 13 total marbles that we are trying to get. So 13 divided by 28 is 46. Is there a decimal? 46.4%. Okay, so these keywords like or, right? And so now we have an or, we have more options. Okay, more options. Black or green, green or black. So let's see, there were how many green marbles?
5.
4 greens and 5 black marbles. 4 greens and 5 blacks makes a total of 9 options. So 9 divided by 28 as a decimal is 32.1%. Okay, so ors, we're going to add the totals together, right, before you divide by the total number of options. So we're adding together the smaller numbers and dividing it by the biggest one. Okay, if you choose 2 marbles at the same time, right, so you're reaching your hand in and you're grabbing 2 marbles, not just one, what is the probability of drawing a blue and a green? Okay, so let's think about these independently. What about just a blue marble? That's 6 out of 28. Times, right, we're having even more probabilities, so we're going to multiply these probabilities together, right, because it is less likely that you're going to choose 2 of the same one. So 6 out of 28, and then how many greens? 4 out of 28. So we're multiplying their probabilities together. So 6 times 4 is 24 over 28 squared. Right? 28 times 28. This is how we multiply fractions. Top times top and bottom times bottom. So we're looking for more, right, more specific things. And the more specific things you're trying to get, the less probable of it actually occurring is. Okay, which comes to about 3%. So not very likely, right? This is like playing the lottery. It's not very likely that you're going to pick 6 or 7 numbers out of, I don't know, 50, 100 numbers and get them in the right order, right? Because order matters in those kind of games. Okay, again, 2 marbles at the same time, a red and a black. So what's our red probability? 9 out of 28. And our black probability? 5 out of 28.
7.
So 45 over 28 squared is? 7.2%. So we must make sure that we have a calculator, right? Because this is stuff that you're not going to be able to do in your head. I'm hearing some other options that 7.2 is wrong. 5.7% is what I'm hearing from the majority of my estudiantes who somehow divided good. Okay, you choose 2 marbles from the bag. What is the probability of drawing a green marble, then a red, if you put the first marble back? Okay, so now we're having multiple events. So what's the probability of drawing a green marble? 4 out of 28. Okay, and then you put it back in there. And what's the probability of drawing a red marble? 9 out of 28. Well, that's the next question. There isn't there. So 4 out of 28 times 9 over 28 is 36. Which is going to be somewhere between 3 and 5, it looks like.
So we don't change anything?
4.6%, right? Because you're putting it back, so there's still the same number of marbles as there was before. Now in the next one, what's the probability of drawing a green marble and then a red marble if you do not put it back in the bag? Okay, so we're looking at greens. How many greens are there? 4 out of 28. And then for reds, how many reds are there? 9. But now there aren't 28 marbles anymore, right? Because you didn't put it back. Now there are only 27 marbles. Okay, so we don't have as many options if you're not putting it back. We are missing one marble, and it happens to be a green marble, I guess, or just one marble, but you're not putting it back. So 36 over whatever 28 times 27 is gives us 7%. So a little bit better than before because 28 times 27 is smaller than 28 times 28. Okay, so these are the probabilities that you're going to be studying and working on for this unit coming up here. Okay, but remember, probability is the number of events that you want divided by the total number of events for that. Okay, fantastic.